Today I will discuss about the pole zero form of control system. The transfer function G within bracket S can be also expressed as Gs is equal to K dash is equal to S minus Z1 into S minus Z2 form to the S minus Zm. It is the denominator is S minus P1 into S minus P2 up to S minus P1. It is the pole zero form and it is the pole zero form and their equation where the Z1 Z2 up to Zm are root of the nominator polynomial known as a zero of the system, where Z1 Z2 up to Zm are root of the numerators nominal known as zero of the system and denominator p1 p2 up to pn are roots of the denominator tor polynomial known as pole known as poles of the system. Here the Z1 Z2 up to Zm are the nominator, the polynomial known as a zero, and p1 p2 up to p1 is known as the pole of the system. Here the K is a steady state gain. The denominator of the transfer function is known as the characteristics equation. Note that the root of the characteristic equation are pole note that the roots of the characteristic equation of the characteristics equation are poles of the transfer function of the transfer function Gs. The pole and zero may be real or complex. No. Poles and zeros may be real or complex The complex conjugate pole occur in pair. The complex plane is used to represent the set of poles and zero. The complex plane is used the complex plane is used to represent poles and zeros. The location of poles exhibit the location of the pole, the stability of the system. Regarding the stability, we will study. Next is S-plane. S-plane. The transfer function are complex variable. Variable in transfer function are complex variable, and complex variable is defined by the two the equation. The equation is equal to sigma plus j omega. Here the sigma is a real number. The variable transfer function and the variables of transfer function is g is r complex variable variable and a complex complex variable is defined by the equation S is equal to sigma plus j omega, where the sigma is a real part of S. Where sigma is the a real part of S and omega is the imaginary part. Imaginary part imaginary part of S. A set of all complex coordinate a set of all complex coordinate is a sigma omega from a plane called as plane. The horizontal axis of the plane is known as the real axis. The horizontal axis of this plane is known as uh, the real axis. It represented by s is equal to sigma plus j 0 a 0. Vertical axis is known as the imaginary axis. The vertical axis is known as the imaginary axis. Imaginary axis, and it is represented by s is equal to 0 plus j omega. The graph is the horizontal axis of the s plane is known as the real axis. No, real axis, the it is a horizontal the axis, it is a real axis, or it's a vertical axis, it is a imaginary axis. So imaginary axis, right half of a plane, the side left half of plane, it is s of plane, and the origin is represented by the complex 0, and the origin is represented by the complex 0 s is equal to 0 plus j 0. So it is a s plane. Next is a first order system. First order or system, the most general form of differential equation representing a first order system. Most general form of differential equation represented a first order system may be expressed as tau into dy within bracket t by dt plus y within bracket t is equal to k into x into t, to the first order equation. So where the y into t and x into t the input output variable, and coefficient is tau, and and k are called the time constant. Tau is called the time constant, and k is called the steady steady state gain or simply gain of the system. Simply gain of the system. The the xt and yt is the input output variable of the system, respectively. The transfer function of the system described can be obtained by taking Laplace transformation. While taking the Laplace transformation on the both side of this equation. The Laplace transformation I will discuss on the next class. Today, let's up to first order equation of the system.